Hey, good morning. Welcome to
Awesome Math number 6.
Awesome Math number 6. So we finished up our first chapter today in our number theory book.
Yep.
And I gave you one of the challenge problems. And you were just working on it now, but I thought we would talk about it for a movie. Find all of the perfect cubes between 1,000 and 2,000. Whoa. So what have you discovered so far?
Well, I've discovered that 10 cubed is 1,000.
Okay, 10 cubed is 1,000.
So I know the limit
Okay.
at the bottom. And I think we know that 12 cubed. So there's,
12 cubed is less than 2,000. Why do you think that?
well, because we found that 13 cubed it was like 2197.
Yeah, you just found 13 cubed was 2,197.
So it's probably going to be 12 cubed that is less.
Okay. So what are the cubes between 1,000 and 2,000 going to be?
10 cubed, 11 cubed, 12 and 12 cubed.
Okay, now, one interesting question is does this one count? It said between 1,000 and 2,000.
So I don't think it counts.
Okay, we've got to be careful. Sometimes problems ask, well, they mean including, and sometimes they don't mean including, but I think when it says between, they don't mean including.
So we gotta find 11 cubed and 12 cubed.
Looks like we just got to find 11 cubed and 12 cubed. And you did a really good job finding this. So let's real quick do 11 cubed. In fact, I'll have to erase. Just give us a little bit of room in the board here.
Well,
How do we find 11 cubed?
I know 11 squared is 121. We just have to multiply that by 11.
So 121 times 11. How are you going to do that?
Well, 100 times 10 is 1,000.
Okay, 1,000.
Then
That's 10 times 100.
Then 20 times 10 is 200.
Okay,
Then 1 times 10 is 10.
all right.
Then we just have the 1, so it's just 121.
Very good. 121. Now you could have done the same thing here. You could have just said 10 times 121 is what?
Is 1210.
Yeah, and that's what you have here, 1,210. But when we add this all up, what number do we get?
We get 1, 3, 3, 1. That looks like around Pascal's triangle.
It sure does. So 11 cubed is 1,331. Okay, now let's see what 12. How are we going to figure out what 12 cubed is?
Well, 144
Ooh.
is 12 squared, so we have to multiply that by 12.
Okay, how are we going to do that?
Then, well, we multiply 144 by 10, so 1440.
Okay.
Then 144 by 2, 288. Then it's 1, 6, and then so 1728.
1728.
So and that means that the cubes between 1,000 and 2,000 are 1331 and 1728.
Good job. Want to hear a pretty interesting and fun story involving the number 1728?
What?
So there's a famous Indian
I
mathematician
think I know this one.
named Ramanujan,
Yeah.
and he was in the hospital. And his friend named Mr. Hardy came to see him. And when Hardy walked in, he said, well, I came over here in taxi cab number 1729, but that doesn't seem to me to be that interesting of a number. And Ramanujan, who a lot of people think is one of the greatest number theorists, people who studied number theory ever, he said, oh, it is a pretty interesting number. Why do you think he thought it was interesting?
Well, maybe, I think I read the story and it said it was the first number to be the sum of two perfect squares. The sum of two sets of perfect squares.
It's close. It's close. See what 12 cubed is? It's not perfect squares. It's the sum of two perfect cubes. This is the first number that can be written as m cubed plus n cubed. Sorry. in two different ways. So what are 2 cubes that can add up to 1729 that you know?
12 cubed and 1 cubed.
Okay. What if I told you that 9 cubed
Was 729.
was 729? So what are the other cubes?
10 cubed and 9 cubed.
So that's what Ramanujan said. 1729 was a pretty interesting number. It's the first number that can be written as the sum of 2 cubes in 2 different ways. Pretty fun.
Yeah.
Yeah? Maybe we'll look for the number 1729 today. See if we can find it. Oh, hey. Alright, good job this morning, huh?